So today we talk about scientific notation, which is just another way of writing a number in a different form. And usually scientific notation is used with very large numbers or very small numbers. So a number written in scientific notation, as the definition states, is a number written in the form a times 10 to the n power, where that number a is a number greater than or equal to 1 and less than 10, so it's any real number. And then I have n being an integer, so a counting number that's either positive or negative. And here are some rules for taking a number in standard form and writing it in scientific notation. The first thing we do is we represent our number as a number between 1 and 10, or sorry, 1 and 10. Where 1 is included, 10 is not. We note the number of spaces we move to make that decimal the appropriate decimal. And we note whether we move to the left or the right. If we had moved to the left, our value for n is positive. If we had moved to the right, our value for n is negative. And then remove any unnecessary zeros. So let's go through and do that. I need to take this number, since there's no decimals, and move 1, 2, 3, 4 places to the left. So since we're moving to the left, our power is going to be positive. And my number is 7.5040 times 10. Since I moved to the left, my number is positive to the fourth. And you notice that this 4, or this 0 right here, really has no meaning in the number. 7.5040, since I have no actual value of that 10,000 spot, I can remove it. So my number is just going to be 7.504 times 10 to the fourth. So let's look at this next example. I move 1, 2, 3, 4, 5 in order to get a number between 1 and 10. And I'm moving 5 to the right. So I know my n value is going to be negative. So in this case, I have 7.02 times 10 to the negative fifth power. And those are my two numbers in scientific notation. So now we're going to move from scientific notation to back to standard form. And here are the steps involved in that. First, we're going to note whether my power is positive, greater than 0, or negative, less than 0. If my number is positive, we're going to move the decimal place to the right. If my power is negative, we're going to move our decimal value to the left. And then any place I need to fill in with placeholders, I'm going to add zeros. So in this case, I have 6.75, and I need to move 4 places, since n is positive, to the right. So I go 1, 2, 3, 4, and put a decimal. Now you'll notice after moving 2, I run out of numbers, so I'm going to have to add placeholders. So this is 67500, or 67,000. In this next example, since I have an n value, or a power that's negative, I'm going to move that decimal to the left. So I go 1, 2, 3, and put my decimal there. And you'll notice once again, after I've moved one time, I run out of numbers, so I have to have two placeholders. So this is 0.00750, right? And we're going to keep the 0, add these two zeros. We don't have to drop in this case. Now, the next thing we're going to do is we're going to take and simplify multiplications using scientific notation and writing our answer. Now, I don't recommend putting these numbers in standard form, multiplying and then putting them back in scientific notation. We're going to combine the numbers in scientific notation, and the way to do that is take a look at each of the two numbers in two parts. Their real number part and their scientific notation part, or their exponential part. So I'm going to multiply 4 times 1.5, see what kind of answer I get out of that, and then write that. And then look at what 10 squared times 10 to the 6th is. So 4 times 1.5 is going to be 6. And since I'm taking and multiplying numbers with the same base, I must add the powers. So that's 10 to the 8th. And that's done. Next, I have 5.3 times 8.2, and that is going to be multiplied by 10 to the 8th times 10 to the negative 1. So 5.3 times 8.2 is 43.46. And that is basically taken and multiplied by 10, since I add the powers to the 7th. Now I notice this 43.46 is not in scientific notation, so I'm going to put that in scientific notation. Remember, scientific notation, we take and rewrite the number, figure how many places we have to move over. I have to move 1 to the left. So this is really going to be 46 times 10. Since I moved to the left, my power is positive, and that term is going to be multiplied by 10 to the 7th. So likewise, you'll notice I have 10 to the 1st times 10 to the 7th, so this is 4.346 times 10 to the 8th. Problem done. We'll do the same thing with division. So in this case, I'm taking and reducing or dividing 5.2 over 1.3, and that's going to be multiplied by 10 to the 5th over 10 squared. And 5.2 over 1.3 is just 4. 10 to the 5th over 10 squared, we're going to find that largest exponent. I have the same base. Subtract the powers. Put the answer where the greatest exponent is. So that's 10 cubed. And we're done. Then we take 1.32, divide that by 2.4, multiply that answer by 10 to the negative 6th over 10 squared. 1.32 divided by 2.4 is equal to 0.55. I could say 0.55, it doesn't really matter. And then I have 10 to the negative 6 divided by 10 squared. Again, we're going to find the biggest power, which is in the denominator, and subtract. So I have 2 minus a negative 6, which is 8. And I put that answer in the denominator, which is 1 over 10 to the 8th. However, we're writing this in scientific notation, so we have no fractions. So this goes 0.55 times, take the reciprocal, I got 10 to the negative 8th. Now, you notice 0.55 is not in scientific notation. I'm going to take and do that. So I'd have to move my decimal 1 to the right, giving me 5.5 times, since I moved to the right, my exponent's negative, 10 to the negative 1. That would be multiplied by 10 to the negative 8th. Same bases of 10s, so I'm going to add the powers, so that's 5.5 times 10 to the negative 9. So here's a word problem. You got Avogadro's number is an important chemistry concept, and it states that 6.02 times 10 to the 23rd is equal to the number of molecules in 12 grams of carbon-12. And we want to use that number, 6.02 times 10 to the 23rd, to determine the number of molecules in 5 times 10 to the negative 7th grams of carbon. So if this 6.02 times 10 to the 23rd is the number of molecules in 12 grams, I want to know how many in 5 times 10 to the negative 7th. Well, I can do a proportion in this. I can say 6.02 times 10 to the 23rd is to 12 as how many molecules is to 5 times 10 to the negative 7th. Just a proportion. So, do my multiplication, and I get 6.02. 2 times 10 to the 23rd. Multiply that by 5 times 10 to the negative 7th. Divide all that by 12, and that's going to equal x. So let's go ahead and do this math. We get 30.11 times 10. I'm going to add the exponents to the 16th over 12. Now I'm going to do 30.11 divided by 12. So I've got 30.11 divided by 12. That's going to be times 10 to the 16th. Turns out 30.11 divided by 12 is about 2.509. And I'm just going to multiply that by 10 to the 16th. And that's all we got. So write your lesson summary and solve the 2 problems below, and we'll talk to you tomorrow.